Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about closed loop transfer function or overall transfer function for negative feedback control systems. This is linear control systems, lecture series on linear control systems, lecture number 18. So our topics name closed loop transfer function or overall transfer function calculation for negative feedback control system. Then overview. Canonical form of closed loop control systems. Forward path transfer function, feedback path transfer function, open loop transfer function, overall transfer function, negative feedback closed loop control systems, positive feedback closed loop control systems, positive negative feedback closed loop control systems, unity positive negative feedback control systems, concept of characteristics equation and effect of feedback control systems. These are all overview or our targets. So canonical form of negative feedback control systems. This is the input signal R of S. This input may be step, ramp, parabolic, impulse, any type of input you can apply. And this is the summing point or adder or comparator, regulator. And this signal always positive. Reference input or set point or cause. This is also called cause. Always positive. And this is the control elements and control systems. This is the gain G of S and E of S is called actuating signals or error signals. And C of S is called controlled output, or this is the effect of the control systems. So this path is also called forward path. This is the forward path where reference input R of S and E of S is actuating signal or error signal. G of S is gain of the system and C of S equals to controlled output. So this is the forward path. This is the forward path. Then feedback concept. This is the feedback element H of S and feedback primary feedback signal B of S, and this is also called feedback signals. And these signals may be positive, may be not negative, but in our this lecture for negative feedback control system, that's why this is negative feedback. This is the negative feedback. Then R of S equals to already discussed reference input, set point or controlled variable. And C of S, this is the C of S, and this C of S equals to controlled output or controlled variable. This is also called effect of the systems. And E of S equals to actuating signals or error signals. And G of S equals to forward path gain or forward path transfer function. This is the forward path transfer function. H of S equals to feedback element or feedback transfer function, and B of S equals to primary feedback signals or feedback signals. So this is the negative feedback closed loop control systems basic block diagram. Then forward path transfer function. What is the forward path transfer function? This is the closed loop block diagram, and this path is called forward path, where RS equals to reference input, E of S equals to actuating signal or error signal, G of S equals to control elements, and control systems, and C of S equals to controlled output. So this is the forward path. And in this forward path, G of S equals to what? G of S equivalent to output C of S divided by E of S. Output C of S divided by E of S, or C of S equals to G of S into E of S. So forward path transfer function G of S equals to forward path transfer function G of S equals to C of S divided by E of S. That means control elements and control system G of S equals to controlled output C of S divided by actuating signals or error signals. This is the forward path for negative feedback control systems. Then feedback path transfer function. Feedback path transfer function, this is the general block diagram, and this is the feedback element measurement or feedback element H of S. In this case, H of S equals to what? H of S equals to feedback transfer function. This is equivalent to B of S, primary feedback signal, divided by input C of S. In this case, this is the C of S and this is the B of S. That's why H of S equals to B of S by C of S, and B of S equals to C of S into H of S. So feedback path transfer function H of S equals to B of S divided by C of S. This is the feedback path transfer function concept. Then open loop transfer function. Open loop transfer function for a closed loop system, because this is the closed loop block diagram. Closed loop block diagram. So calculate open loop transfer functions. Open loop transfer function. Ratio of the output of the feedback path B of S to the actuating signal E of S for any given feedback loop. In this case, this is the B of S primary feedback gain, and this is the actuating signal or error signals. So feedback open loop transfer function equals to B of S divided by E of S, primary feedback signal divided by actuating signal or error signal, and this is equivalent to C of S by E of S into B of S by C of S. What is the C of S by E of S? C of S means output, controlled output, and E of S equals to actuating signal, and this is equivalent to ultimate G of S. G of S. Similarly, B of S, this is the primary feedback signal B of S, and divided by C of S equivalent to controlled output, and B of S, this is the output divided by input, equals to H of S. So open loop transfer function B of S by E of S equivalent to Z of S into H of S. That means product of the forward path gain and feedback path gain is called open loop transfer function. This is the open loop transfer function concept. Then overall transfer function for negative feedback control systems. This is our actual focus or target. What is the overall transfer function? The ratio CS by R of S. That means controlled output by reference input. This is also called, this is the effect C of S, effect by cause is called the overall transfer function for a closed loop systems. Then CS by RS equals to GS by 1 plus Z of S into H of S. This is our target. So prove that the overall transfer function C of S divided by R of S equivalent to GS by 1 plus ZS SS. This is the target or focus in this lecture. Then canonical form of the closed loop transfer function. Canonical form of the closed loop transfer function G of S system gain and E of S equals to actuating signal or error signals. Then output, controlled output C of S. So from figure, this is our open loop or forward systems or open loop systems, where E of S equals to input and G of S equals to gain of the system and C of S equals to overall output. Then in this figure, C of S equals to G of S into E of S. C of S means controlled output equals to G of S. That means this is the gain of the systems, and E of S equals to input of the system. This is equation number 1, because control gain G of S equals to, or transfer function G of S equals to C of S output divided by input E of S, where C of S equivalent to G of S into E of S, product of G of S into feed actuating signals or error signals. This is the, then connect reference input with comparator or summing point. This is the always forward. This is also always positive, and then connect feedback element H of S, and this is the feedback path, and this is obviously negative feedback, so this point negative, and B of S equals to primary feedback gain or feedback signals. Then the transfer function of the closed loop system can be reduced as follows, where E of S actuating signal or error signal, E of S equivalent to R of S reference input minus B of S. This is equation number 2. So in this case, E of S error signal equals to this signal R of S minus feedback signal B of S, So E of S equals to R of S minus B of S. This is the equation number 2. Then B of S equals to what? This is the primary gain. This is the primary gain, B of S, primary feedback signal gain. B of S equals to what? B of S equals to C of S into H of S, because in this is the feedback path, where H of S equals to feedback element, B of S equals to output, and C of S equals to controlled output, where H of S feedback element equals to a transfer function equals to output B of S divided by C of S. So B of S equals to what? C of S into H of S. B of S equals to CS into H of S. This is equation number 3. This is the equation number 3. So canonical form of the closed loop system, equation number 1, this is equation number 2, and this is equation number 3. Eliminating B of S from equation 2 and 3. So our target, first eliminate B of S. First target B of S. Eliminating B of S from equation 2 and 3. Then we have E of S equals to what? E of S equals to RS minus B of S. RS minus B of S. And B of S equals to also CS minus H, CS into H of S. So put B of S equals to CS into H of S, because B of S equals to C of S into H of S. So put here C of S into H of S. Then this is the equation number 4. B of S equals to C of S into H of S. This is equation 4. ES equals to RS minus CS into H of S. Then eliminating E of S from equation 1 and 4. So this is our equation number 1. This is our equation number 1, and this is the equation number 4. Eliminating E of S. That means this is the E of S, or this is our equation number, and this is U of S. So put here E of S. Put here this value E of S equals to RS minus C of S into H of S. Just put here R of S minus C of S into H of S. Then we get C of S equals to, this is C of S, G of S common, and U of S equals to R of S minus C of S into H of S. So put here R of S minus C of S into H of S, because this is equivalent to E of S. This is equivalent to E of S. And E of S equals to RS minus C of S into H of S. Then multiplying G of S into R of S minus G of S into C of S into H of S. This is equivalent to C of S, output C of S, or controlled output C of S. Then C of S equals to G of S into R of S minus G of S into C of S into H of S. Then C of S plus G of S into H of S into C of S. Just this is the shifting left hand side. Then we get CS, left hand side CS plus, this is the minus side sign, that's why this is plus, and GS into GS CS into H of S. So this is the left hand side equation, and right hand side just G of S into R of S. Right hand side just G of S into R of S. This is the right hand side. Then common C of S. Left hand side, this is C of S also, this is C of S. So common C of S, and we get 1 plus G of S into H of S into C of S equals to G of S into R of S. This is the right hand side terms. Then C of S equals to what? Just C of S equals to G of S into R of S divided by 1 plus GS into HS. So C of S equals to G of S into R of S divided by 1 plus GS into HS. This is the controlled output for negative feedback closed loop systems. For negative feedback closed loop systems, the output C of S, this is the controlled output, or this is the effect of the system, equals to forward path gain into reference input divided by 1 plus GS into H of S. So in this case, RS equals to R of S equals to reference input. In this case, R of S equals to maybe step, ramp, parabolic impulse, sinusoidal, analog signal, digital signal, any type of input you can apply. And 1 plus G of S, H of S. 1 plus G of S into H of S equals to 0 is called characteristics of the systems. And this characteristics equation gives the system stability, because if all the roots or all the poles of the system left hand side of the S-plane, then system will be stable. So this is the very important, because this equation is called the characteristics equation if this is equals to 0. Then CS by RS equals to what? Just divide both sides RS, and we get CS by RS. CS equals to overall system output, and RS equals to reference input, and output by input equals to what? G of S divided by 1 plus GS into H of S. So this is called the overall transfer function for a negative feedback closed loop system. And in this case, 1 plus G of S into H of S. This is for negative feedback systems. That's why this is positive, and 1 plus something, that means this value maximum, denominator value maximum. That's why CS by RS ratio minimum or less. So efficiency or transfer function, overall transfer function minimum. In this case, For negative feedback system, this is the very important, because in this case 1 plus something, so ratio of GS by 1 plus GS is equals to less. That's why CS by RS equals to less. Negative feedback closed loop control systems. This is the R of S reference input, and this is comparator and error signal, G of S system gain and or planned gain, and C of S equals to overall system output, H of S equals to what? H of S equals to feedback element, and this is the feedback, primary feedback gain B of S, and this is the feedback signal, and minus negative feedback. Hence, the above feedback system can be reduced to a single block diagram shown in figure below. R of S equals to what? Reference input, and G of S divided by 1 plus GS equals to overall transfer function, and output equals to C of S. So CS by RS equals to GS by 1 plus GS. That means CS by RS equals to G of S by 1 plus G of S into H of S. This is the block diagram or single line block diagram, open loop block diagram. Then positive feedback closed loop control system. This is the positive feedback closed loop control systems, already discussed. Just feedback path only positive. This is the positive feedback. That's why this is called positive feedback closed loop control system. This is the positive feedback closed loop control system. For positive feedback closed loop control systems, the transfer function is as CS by RS, CS overall system output divided by reference input equivalent to GS by 1 minus G of S into H of S. In this case, 1 minus something. That's why this is minimum. This is minimum, and ratio of the CS by RS maximum. Ratio of the CS by RS maximum. That's why in this case, the transfer function CS by RS value or ratio of the value maximum or high. Then the single block R of S equals to reference input GS by 1 minus G of S equals to, and output equals to C of S. Again, C of S by R of S equals to GS by 1 minus GS into SS, where 1 minus GS equals to 0 is called the characteristic equation of the systems. So positive negative feedback system. If in this case, this is positive or negative, then the positive or negative system, the transfer function is as. For positive, this is the negative value. For negative, this is the positive value. So CS by RS equals to GS by 1 minus plus GS into SS. So this is the transfer function, and in this case all the initial conditions are zeros, and RS equals to reference input and block gain GS by 1 minus plus GS into SS equals to C of S. So for positive negative feedback, this is the negative positive. If in this case negative positive, then this is positive negative. Just sign change. This is the positive negative feedback control systems. Unity positive negative feedback control system. If H of S equals to 1, then this signal is called unity positive negative feedback control systems. H of S equals to 1. This is closed loop system, but feedback gain magnitude equals to 1 only. Then we get the unity feedback system. The transfer function is as CS by RS, again controlled output divided by reference input equals to what? Equals to GS divided by 1 minus plus G of S. In this case, H of S equals to 1. So single block is as R of S equals to reference input and block gain GS by 1 minus plus GS This is the GS by 1 minus plus GS, and output equals to C of S. So again, C of S by R of S equals to GS by 1 minus plus GS. In this case, SS equals to feedback equals to 1. Feedback gain equals to 1. So concept of characteristics equation. For positive feedback system, the transfer function is as CS by RS equals to GS by 1 minus CS SS, because this is positive feedback. For positive, this is the negative. This is the negative signal. Then the denominator 1 minus G of S, H of S equals to 0 is called the characteristics equation of the system. And for negative system, the negative feedback system, the transfer function is as CS by RS equals to what? Just sign change, GS by 1 plus G of S, H of S. This is for negative feedback transfer function. C of S by R of S equals to GS by 1 plus GS H of S. And the characteristics equation is 1 plus GS into H of S. In this case, this is the characteristic equation. And for negative feedback system, this is the characteristics equation. Then effect of the feedback control system. What is the effect of the feedback control systems? The error between the system input and output can be reduced by using feedback technique. By using feedback technique, error between the system input, that means reference input, and the output can be reduced. Gain may be increased by gain amplification. Feedback can be improved, the system stability. Feedback can be increased or decrease the sensitivity of the system. This is also very important sentence. Feedback can reduce the effect of the noise and disturbance. Feedback increase the accuracy of the system. Feedback reduce the steady state error. Feedback reduce the effect of the nonlinearities and distortion. Feedback increase the bandwidth. Feedback stabilize and unstable systems. This is the very important effect of feedback control systems. Effect of the feedback control systems. Thank you.